the most used and perhaps least understood facets of machine operation is lubrication. Metal parts must be separated from one another when in operation, or rapid wear and deterioration will result. This separation can be provided in the form of oil, called lubricant. Choice of the right lubricant can be difficult unless all lubricants and their qualities are understood. To rub one body against another, a resistive force must be overcome. This opposing force is known as friction. Friction exists in several forms, and all are measurable. In some respects, it is very fortunate that friction exists. Without friction, walking would be impossible, and an automobile, or a brake, or a grindstone would be useless. On the other hand, almost all mechanisms involve the sliding of one part against another. Here, friction is undesirable. Work is required to overcome this friction, and the energy thus wasted entails a loss of power and efficiency. The principle of supporting a sliding load on a friction-reducing film is known as lubrication. The substance of which the film is composed is a lubricant, and to apply it is to lubricate. These are not new concepts, nor particularly involved ones. Farmers lubricated the axles of their wagons and ox carts with animal fats centuries ago. Modern machinery, such as the modern car, has become many times more complex since the days of the ox cart, and the demands placed on lubricants have become more exacting. Though the basic principle, the prevention of metal-to-metal contact by means of an intervening layer of fluid-like material, still prevails, modern lubrication has become a complex study. Lubrication can be defined as the separation of two sliding bodies by a fluid or fluid-like film. Thus, the two bodies slide over this film rather than over their own surfaces. In this manner, friction is reduced. Lube stock comes from the pipe stills, then goes through a solvents extraction process on a hydrofiner, then to the de-waxing and de-asphalting units, where wax and asphalt are removed. Additives and blending stock are mixed in to form a finished lubricating oil. The basic petroleum lubricant is lubricating oil, which is often referred to simply as oil. This complex mixture of hydrocarbons represents one of the important classifications of products derived from the refining of crude petroleum oils. And although it is readily available in a great variety of types and grades, it is best not to mix refined grades of oil, as some oils do not mix. Mixing some oils cause them to precipitate and form sludge. In addition to oil, there are other types of lubricants. Water and even air are used as lubricants in some applications. However, for purposes of our instruction, we'll concentrate on the more common types of lubricants and how they are applied. Let's consider grease as a form of lubrication. Grease is an oil that has, in most cases, been thickened with soap or lithium to give it a plastic consistency. The effect of the thickener varies. Some thickeners serve only as a binder for the oil. Others work with the oil to provide greater lubrication than oil alone could provide. The consistency of grease offers certain advantages. It will remain in place and provide continuing lubrication in bearings where oil would leak out. In some plants, it is important that the lubricant does not drip or spatter, thereby contaminating the product. In these cases, grease is preferred for its adhesive qualities. Also, under certain conditions, grease is a better sealing agent than oil. This is especially important in wet and dirty conditions, or where corrosive fumes are present. A grease for almost any purpose can be produced by varying several factors: the type of oil, the type and percentage of thickener, and the method of manufacture, including any special additives. Product streams are a form of lubrication sometimes used. Product stream lubrication is essentially the lubrication of parts of equipment utilizing the product flowing through the equipment. The product may be water, oil, gasoline, or any other substance produced or transferred through the machine. In vertical pumps, like the one shown here, this form of lubrication is quite often used. Back for a few moments to oil as a lubricant. Oil has these advantages over grease. It can be used at higher speeds for longer periods of time than can grease. Also, oil is lower in fluid friction and imposes less drag on moving parts. Another advantage, oil can lubricate in closer clearances between moving parts than can grease. Before we look at the properties of lubricants, open your workbooks to exercise number 1 for a review of what we've covered thus far.